Jupiter actually emits more heat than it receives from the Sun. It is contracting in size, which heats it up. This heat eventually makes its way out of the planet through the cloud deck. The heat escapes easiest where the cloud deck is thinnest, which is why features like the Great Red Spot and the white bands in visible light are dark in this image. Luckily, we aren't just limited to a disk view of Jupiter either, thanks to the Juno spacecraft that is in orbit around Jupiter right now. Viewing Jupiter's poles in infrared again, scientists were able to create a 3D map of the incredible vortices that are found there. Jupiter's North Pole has 9 seemingly constant vortices, 8 in a square shape revolving around a large one found right in the center. Again, you'll notice that it is the lowest altitude regions that are emitting the most heat. Because this wavelength only reveals heat, the haze and shadows in the atmosphere don't block the view as much as you would get in visible light, meaning it can give us an unprecedented view of the 3D structure of these vortices. It's still pretty cool here for Earth standards. Even the yellow sections are only -13°C, with the darker, higher altitude regions being -83°C. And because the heat is coming from Jupiter itself, this view is available to Juno night or day. It isn't reliant on sunlight. Storms can show up in infrared before they are noticed in visible light too. Look at this comparison taken by Hubble. These near-Earth-sized storms located beneath the cloud tops are much warmer than the ambient surroundings, indicating that internal heat does play a big role in generating atmospheric disturbances. And while we're on this wavelength, let's also have a quick look at Jupiter's volcano moon, Io. Unsurprisingly, Io's night side is totally lit up by the volcanic activity on its surface, making it very easy to identify new volcanoes and to keep track of the ones we already knew about. Juno has had several looks at Io, each one revealing it to be a hive of activity, a truly hellish yet intriguing world. For instance, here is the Galileo probe's infrared view of Europa in the 1.5 micron water band. When viewing an object through this particular wavelength, we can see locations where water is present. The deep blues in the image are the locations of the purest water ice, whereas other colors indicate a mixture of water ice with other minerals.